Mhm. So starting with the onion diagram, the pinch technology provides a systematic methodology for energy saving in processes and total sites. Here, in the figure, the role of pinch technology in the overall process design. The process design can be represented by the onion diagram. The design of a process starts with the reactor. So the process starts with the reactor in the core of the onion, which brings chemical changes in the feed. So first you select the reactor, then once feeds, products and recycle concentration and flow rates are known, the separators, the second layer of the onion, can be designed. In the slide number 3, there is a second layer, that is a separator. The first part is the selection of reactor, and that you have to consider feed, products, recycle concentration is there. Then come to the point separator. Once you get the product or byproduct, you have to separate it with the help of unit operations. So you have to choose here separator as a one core. The next, the network, the third layer can be designed. The remaining heating and cooling duties are handled by the utility system. The third part, the based on the requirement of heat for the core and second layer, the heat exchange network, that is the third layer. There is a heat exchange network, and in the fourth layer you have to utilize that heat or coldness. That's the part of utilities. That's the part of utilities. You have to utilize it the heating or cooling duties. That is the fourth layer. The process utility system may be part of a centralized site-wide utility system. So I will give you one example on that. So there is one PDF file is there, production of n-octane. Few more explanation already given in this paper related to onion model. You can also see, yeah, production of n-octane. So here you have seen the figure number 4 is the general diagram. Figure number 4, the preliminary flow sheet for the production of n-octane after completion of onion model layer. So here there is a reactor, there is a separator, then some heat exchange network are there, but you have to apply the phenomena of process integration. Okay, the production of n-octane from ethylene as well as i-butane. Okay, so there is a chemical reaction is there. The part of process integration is in figure number 5. Have a look, figure number 5. And what is the difference between figure number 4 and 5? Can you imagine? Yes, there is a temperature conditions are there. It is given. So you have to utilize the condenser duty, heat duty, condenser duty. You may see the distillation column at the top. There is a condenser is there. So you have to utilize that heat. And you may use that heat for heating the fresh feed. Then again, once you have to reach the 93.3 degrees Celsius, You have to use one heater over there. There is another exchanger is there. A per system is nothing but to remove the impurities. Per system is used here to remove the impurities. The converted raw material leaving at the distillation top streams is now pure enough for recycle. A per stream is added before the stream is recompressed, reheated, and sent back to the reactor. The tier stream concept is utilized to facilitate convergence of the recycle stream. In figure number 4 is a preliminary process flow sheet based on the synthesis and simulation conducted. The design of heat exchange network and utility system will be handled simultaneously. Stream enthalpy data needed for the analysis is extracted from the converged flowsheet. Here, they select distillation column to integrate this task. So alternatively, if distillation is not preferred for the heat integration scheme because of the control ability reason, the alternative flow sheet is that you may use another alternatives. So there are multiple alternatives. You can choose reboiler or at the feed section, or you may add heater or cooler at the input section. So there are multiple inputs are available in figure number 6. These are another alternatives. So based on that, you may choose the calculation. You may find out the cost, how much heat exchanger needed, how much condenser is needed, how much alternatives. So which one is the best? You may select that. That is the task. It depends. There are multiple alternatives are also possible in this case. The explanation is already given and example is a simple example is given. So you have to look the flow sheet and temperature conditions. Then you will get the where they use the heat exchangers, where they use the compressor, where they use the condenser. That's the task. Doesn't matter. You may here they use condenser heat duty. Okay, doesn't matter. You can use reboiler duty as well. Reboiler duty, you can preheat the feed by use of reboiler heat. That's also possible, but depends your distillation column operated at what conditions. You have to see first your distillation column operated at what conditions, what are the temperatures, what are the pressures. Okay, also you have to consider the phase, which type of phase is there, liquid phase, gas phase, or solid phase. You have to consider for that. So it is based on the onion diagram. So here there is a reactor, separator, then heat exchange network, and last part is the utility system, where you have to use the heater or cooler